So welcome to this week 11. This is problem 6 in chapter 12, and the problem states that a company institutes an exercise break for its workers to see if it will improve job satisfaction as measured by a questionnaire that assesses worker satisfaction. And we have two parts to complete. The first part is asking us to identify the procedure you would use to assess the effectiveness of the exercise program and to check if the conditions allowed for the use of that procedure. Now, just to sort of recap, the three tests that we can use for this, we can use a pair t-test, which is an hypothesis test for the mean of pairwise differences of two groups. So we're always talking about comparing two groups. The two sample t-test is an hypothesis test for the difference in mean of two independent groups. So that's a significant difference here. These groups are independent and you use the two sample t-test. If the groups are not independent, then we would use a paired t-test. And in this case, just to hasten to the conclusion, these results are the pairs. So we have a pair here and we have another pair here. If you examine how these data were collected, this 33 and this 37 are both related to the same worker, number 4, who was selected. So definitely these cannot be considered to be independent. So the two sample t-test would not be what is used here. Other situations, if you have people who are related or are in similar positions, and that's gonna be that information you're gonna get by understanding how the data was collected. So if you're working with secondary data, then you have to get as much information as possible on how the data was collected. The other possibility is the pool t-test, which is used for independent groups. So it's going to be a more specific two sample t-test almost, because it would have had to meet that condition in order to be considered for a pool test. But beyond the basic two independent groups, we have to be willing to assume, and this is the important part here, willing to assume that the variances of the groups are equal. So that's a significant difference with the two sample t-test and the pool t-test. Now getting back to the problem, certainly we are going to be using a paired t-test here. There's no reason to move on to anything else because we know that these two sets of data are related and strongly related. Now the assumptions are sort of detailed here, where we want to make sure, were these randomly selected, we would assume that they were. If we hop real quick to the data in Stats Lab, in Stats Crunch, you can see that the difference, I worked out the differences here between the before and after, and we can do a quick histogram of that to see what it looks like, and it gives us an approximate bell curve. Is it a perfect bell curve? Certainly it's not, but I think it's enough to move on to assume that the difference is normalized or normally distributed. We don't have enough information to determine if the sample size is what it meets the 10% condition, but you would mention that to show awareness of it and all that. But we don't have enough information to assume or to see if it is. The second part, we're wanting to test an appropriate hypothesis. Now, the null hypothesis is clearly that the difference is 0, and the alternative hypothesis, since we want to make sure that the after is greater than the before. That's the only difference we're interested in. So it would be a one-sided test, and it's going to be that is the difference is greater than 0. So it's all of the calculation is done here for you in the view and example by hand almost. You can take a look at it and follow through with that. And we hasten to the results, which is here. And I'm going to hop over to StatsCrunch and quickly do the statistical analysis by hitting stat. We know it's a t statistic, and it's going to be a paired t statistic. The first set of data is going to be the before, the second set of data is going to be the after, and we are going to do the hypothesis test, and we want to do a one-sided test with mu1 minus mu2 being less than 0, so that it is mu1, which is before, being less than mu2. So selecting this is important, and you know it's one-sided, but you have to decide if it's greater than or less than, and then you have to look back at this relationship and how it was created to make sure we're looking for an increase and not a decrease. So if we hit compute here, StatsCrunch spits out this information, and the p-value is 0.014. Degrees of freedom is 9, and that's what they did here manually. And the conclusion is that we can reject H0 since the p-value is 0.0014, which is less than alpha. So therefore we can reject H0, and if you recall, H0 is saying that the difference is 0, so we will accept the alternative hypothesis that the difference is greater than 0. So hooray to the person who came up with this idea. Statistically, we have shown that it has resulted in an improved job satisfaction. Alright, so feel free to reach out to us if you have any questions, and thank you for watching.